Righto. So tonight Martin and I are going to talk about those things to do with repeaters, and we'll end up with a tour of the VK6 RMH repeater at the SES headquarters. So, my background, for a couple of years, I suppose, I looked after the repeater at Wireless Hill, and that was kind of where my interest came. Martin, would you like to have a chat about your interest in repeaters?
My interest in repeaters is simply being one of an amateur operator. I was never a technician of any kind, apart from audio and playing trombones.
That's technical.
But for me, an amateur radio license is an experimental license, and I've followed that philosophy from when I got my first license in 1980. And we, as a club, we thought it would be a good thing to have our own little repeater, which we could use deliberately with the antenna kept low, so it services this area here. So I took it upon myself to learn how to tune cavities, found the radios, the club purchased them, and with significant help from Will 6UU, and a final little tweak of some capacitors on the duplexer from Ray. ZRW, yep. We got the thing nicely tweaked and operational. So that's basically it.
All right, very good. So I guess bottom line is I have some knowledge of repeaters, but it's very old. Martin has some knowledge of repeaters, and it's much newer. So Martin, as we go, Martin will update me with, no, we don't do it that way anymore. I hope. Okay, so let's roll on here. So we're going to talk about the what, why, and how of repeaters. So to start off with, what is a amateur radio repeater? Simply a transmitter and a receiver connected together to extend the range of available contacts on VHF, primarily 2 meters and 70 centimeters. So why? As a lot of you know, on VHF, so above 30 megahertz, under normal conditions, you normally get coverage, VHF coverage of about 30 kilometers. So about line of sight. Because of the curvature of the Earth, the range is reduced by topography, by buildings, trees, reflected signals. Everything acts to reduce the normal range, particularly for mobile and handheld use. So the beauty of being able to operate a repeater by putting it up high, because of the greater height, you can the repeater can actually see a lot further. So you can extend the range of VHF simply by adding a repeater. So repeater, VK6 RMH aside, many other repeaters are located at height. So the repeater will receive signals from a greater distance, and it can retransmit those signals over a greater distance as well. By locating a repeater at height, say on top of a mountain, you can receive signals from a much greater distance on VHF and UHF, and in turn transmit them a much greater distance. So that overcomes this line of sight situation that you get with VHF. So as an example, the RAP repeater at Rolling Stone, as you can see, It can be used reliably from a mobile situation from Yanchep all the way to well south of Mandurah. And
you can see where Mandurah is on there.
down there.
Yeah. And you can see how we're very much in a very strong part of the footprint from Rollystone. So, whereas some of our members have trouble getting into our repeater here from Rockingham. And the reason for that is simply the height of the Rollystone repeater, whereas this one is as high as this building here. And this is about the highest spot in Mandurah. So that's, I mean, if we wanted that sort of range, then we would have put this one up on the hill somewhere. There's not a lot of point in that because it's well catered for. We have Mount William, of course. You've got RAP there, and you've got RTH Tickhill further up in that white area north of the city. And our repeater was designed to be an emergency comms thing. In a severe cyclone, there's a good chance the repeaters all the way along the scarp, not just amateur, but everybody's will be damaged. But this one, the antenna breaks off, we can climb up that for 7 months that long. And we have secure comms for our local area. Over to you, Mark.
Yeah, thanks, Martin. Any questions or comments? Other questions or comments? Righto. Martin and I were talking before. We'll do another discussion chat, I suppose, about repeater linking, and we'll probably run the same sort of analysis of the Mandurah repeater and probably the Mount William repeater to look at coverage, and hope so. That'll be for another night. Righto, on. So let's talk about the basic configuration of a repeater. So we start with a receiver, VHF receiver, a VHF transmitter connected via the output of the receiver, the audio output of the receiver connected to the transmitter. Then a little bit of control circuitry is added. So a carrier operated relay, turn the transmitter on, detects a carrier coming in, closes the switch and turns on the transmitter, and hence the transmitter retransmits the audio from the receiver. A couple of other things are added for licensing requirements, an ident. So that's the Morse code ident that you can hear on VK6 RMH, and a timeout timer. So that when you're like me and you talk for more than, 10.5 minutes per over, the time's out. So, and Martin, we think it's about 3 minutes on RMH, yeah?
That's what I set it to, but I think it's a bit shorter than that. I think it is. It's probably around about 2 minutes.
Yeah, I reckon it's much shorter than that. as somebody who times out all the time because I talk too much. Righto. So that's the basic configuration of a repeater. Here's a picture of one of the repeaters that Will built a few years ago, 6UU. And so you can see here a receiver in a box, transmitter in a box. The control circuitry went in here, and over the back there's a whole bunch more things, but primarily a receiver and a transmitter. And I'll talk about why they're in separate boxes a little later. Turn it over. No, not turn it over, fill it out. That's right. So the receiver's now in its shield. There's a power amplifier, and there's the CW ident board. What else have we got? Mains failure voice alarm. Whew. And underneath, all sorts of goodies. And So it looks like DTMF. So this is touch tone type decoder. So you can jump on the microphone and push the buttons, and it and can do various controls. We've got, this looks like an audio mixer here, and various other bits and pieces that have been added. A lot of it's to do with allowing repeaters to be, things like the timeout timer to be turned off for Wireless Institute news and so on. Righto. And this is the Mandurah repeater, K6RMH, which Martin has built.
Using two Woshens, identical rigs, and what were they again?
They're Woshin KG-UV902P.
That's what I was going to say.
Yeah.
All right. So yeah, they're identical dual band VHF UHF rigs, and I researched, found these, and they have a beautiful little port on the left-hand side here where this Cat5 goes into, and that allows you to connect the two rigs as a repeater. So this one operates as the receiver, this one operates as a transceiver, as the transmitter, and this line here conveys the audio received on the input to the transmitter, and out it goes. And that's fine. That's all you need, and it works. Except there's no ID, there's no nothing, and there wasn't even any documentation on the pinout of those two sockets. So I had to experiment and try to not let the smoke out, which I managed to avoid. And then I needed to find the COR, as carrier operated relay. And simply that is when this receiver detects an incoming signal, it sends the line high, I think it's high rather than low, one way or the other, to tell you that there's a signal coming. And when there's a signal, when that line goes high, then this thing will switch to transmit. Now, we have to, by law, identify it, and that's where this board, this is the ID-O-Matic version 4. I think they might be up to 6 now. And this is a board produced by somewhere in America. And what it does, hamgadgets.com. There you go. It takes a sample of that COR line to tell this that there's a signal coming through. And that starts the counters going, the timeout, and then also once it drops, another timer is going to identify some 30 seconds after the last carrier, and it'll come up and just identify the repeater. But also during a QSO, it will it'll send the CW ident at a low level. You can have a CW ident, or you can record your own voice identification. I thought we'd stick with the CW because it's traditional, I guess, but also it keeps CW going in some way. Now that we don't need to have it.
But it also transmits regularly with the station's quiet, isn't it?
Yes,
as well.
I've set it to do that about, it might be once every half hour.
Yeah.
Yeah, I think I set it to that. So it'll just come up and say, "Hi folks, I'm here," just to keep the channel busy. You've got various adjustments for audio to come out, and it runs on USB 5 volts. And that one is live, the LED's on. So that actually lives in here. So, but the beauty with these two rigs just made it a breeze. So the actual building of the radio side of things was just a matter of plugging in. So finding radios that actually have COR on them is tricky because not all of them do. So that, you know, I had a number of radios that could have been used, but no COR. So we looked and found those. Any questions on that?
How did you go about programming that? How did you go about getting it all interfaced?
Oh yes, the programming.
Is it something you can bring up on a computer screen?
Yes, the programming comes in through the little serial port there.
Okay.
And,
a special program of some sort you need, or?
No, it's just serial columns and serial terminal like button.
Yeah.
You just type in there with probably the appropriate passwords and things, of which I have all the instructions at home somewhere. Yeah, so you're actually dialing, and you could connect that. For example, that could be hooked into our mesh network, and I could, from home, dial into it. But we haven't done that yet. That's a thought.
That's a modern board we got there.
Yeah.
A question for Mark, I guess. Mark, with the original RAP,
Yep.
was the ident done with a board like that or done by some other more ancient means?
It was a lot of fun. It was a lot of fun. We actually learned a lot about, for the first time in my time anyway, Boolean algebra. So the whole thing was done using diodes, so individual little diodes that got soldered onto a printed circuit board sort of thing, and it's like a clock arrangement that would ripple through and really activate the diodes, and just depending on where it was in the cycle, it would say yes I want to send a tone, or no I don't, and together you could build up a tone, so or an ident, but that's all it did. Whereas this board does all the timing and all the other flash things. In the days, yes, they were all done using really hand programmed, using diode OR gates, and a lot of Boolean analysis. So that's analysis of ones and zeros and gates, simple gates, logic type gates, to come up with a system that would make the ident sound. Quite fascinating.
So Mark, was it limited to CW, or could you have an audio ident with that old system or not?
Paul, only CW, and in fact, in those days, whoever it was, Department of Communications or Transport and Communication, anyway, whoever before the ACMA existed, they regulated amateur radio and repeaters much more than now, to the extent that to be licensed, it required Morse code ident and a whole bunch of other requirements. And I was talking to Martin before when he asked how come the first two repeaters in Perth were RAP and RAH, why not RWH for Wireless Hill or something like that? Well, the regulations were you could only have call signs in Australia starting with VKX RA something. You could only have 26. So anyway, I think it was Will came up with the idea on RAP that yes, we needed a Morse ident, but there was nothing to say it actually had to be audible. So he actually, I don't know if RAP is still the same, but he introduced frequency shift keying. So the carrier would shift by a kilohertz or half a kilohertz or whatever. So if you tuned with a single sideband receiver, you could hear the Morse ident, but you wouldn't. It didn't, annoy the operators. So it did have ident, and it did have Morse ident in accordance with the law, the rules, but you couldn't actually hear it, which I thought was pretty clever. Right. Any other questions? On. Thanks, Martin. That's terrific. Oh, actually, I do have a question, Martin. You said you can record audio, so yes. You can have an audio ident, as you said. Does it also come with a standard electronic voice, or like if you don't like your own voice?
I don't know that offhand, but I do know it was a recording you could upload.
Okay.
Maybe it does have a robo voice.
Yep. Reason I ask, so where I am, I'm on the edge of the Riverina repeater network, where there's about half a dozen 2-meter repeaters and 70-centimeter repeaters all linked together, and the ident actually it's a voice ident, and it says this is the linked repeater network of VK2, goes through it all and states where they are, and it also then says all repeaters require a 91.5 hertz subtone for access. So it gives you the subaudible tone that you need, and it also from time to time it'll come up and it'll say at 9 p.m. in Temora the temperature was whatever it was. And there has been, 3 millimeters of rain, sort of thing. So, yeah, all sorts of cute things. All right. Any other questions? Seeing that was my question. All right. On. Next one. So, as I said before, by that block diagram, transmitter and receiver. This isn't too hard, folks. What would happen if we transmitted and received on the same frequency?
We just would cut.
I think you've discovered that electronic equipment is made of smoke.
What happened to my 817?
Yeah.
Is that what you did? Righto. So if you transmit and receive on the same frequency, lots of strange things are going to happen. The receiver is going to pick up the transmitter immediately. There's going to be feedback and chaos, and it's just not going to work. So you can't transmit and receive on the same frequency where the transmitter and receive antennas can see each other. So it just ain't going to work. So in Australia, on amateur bands, we have a standard 600 kilohertz offset on 2 meters. That means for 99.x% of the repeaters, you transmit 600 kilohertz lower than you receive, or the repeater does the opposite. And on 70 centimeters, for the user transmits 5 megahertz higher in frequency than you receive. Right, so here's a list of the 2-meter repeaters in WA, and of course, where are we? Mandurah. So the repeater in Mandurah transmits on 146.850 and receives 600 kilohertz lower on 146.250, which means for you to get into the repeater, you need to transmit on that 146.250 and receive on 146.850. Righto, all of the repeaters in Western Australia, from the looks of things, are that way around. Yep, so they all, you shift your transmit frequency 600 kilohertz lower than your receive frequency.
No, the high ones.
147.
Say again?
About 147, though, some of that change.
Yeah,
About 147.
Oh, yeah, I'm sorry, you're right. And yeah, Martin corrected me about this before. Once you go above 147 megahertz, it switches around. You transmit 600 kilohertz higher, righto. And the reason for that is because of those the paging systems on 147, 0125 sort of thing that cause everybody such dramas. So better to reverse. So you're transmitting up the top end of the band, and your receivers are a bit lower down. All right, happy with that?
It's good to see we're in the list at last.
Yeah.
We've made it. We've actually made it.
And
Yep, sorry, Jerry.
yeah, look, I was just wondering about the conflict with Exmouth. I mean, we were talking about doing some fancy stuff with tone control. Are we going to just leave that and put it on hold, and no one's complaining, just leave it alone?
Well, nobody's complaining at the moment because it's winter, and Bruce has stitched together a CTS. I got it right? CCTS? CCCSS. Something like that.
A subaudible tone thing.
Yeah, that's it. And that's currently in my shack at the moment. So it's sometime before the next hunting season, I'll try to get that in, and we'll lace with you guys on the subtone. And the idea will be to anybody who wants to chase ducting up the coast to Exmouth, they will set their rigs to transmit that subtone, whatever it'll be, and which will, on reception of that carrier with that subtone, our repeater will throw a relay on the PTT line. And so when the repeater tries to go to transmit, the PTT line will be broken, and it won't switch on. So that will allow those people trying to chase the ducting up the coast to hear the response of Exmouth if it's there, without getting trodden on by us.
One or two in the state.
But that's largely affecting people who live on the scarp or reasonably high or close to us. People that are not close to us and down in the metro area won't hear us at all. But it'll help in that regard. The other solution is to work with the repeater group and see if we can't get another frequency suggestion from them, and then retune our cavities and just get off that frequency altogether. That's easier said than done, because I think just about every repeater pair that ever there was has been allocated. And in my initial discussions with the repeater group, it was suggested that we use that pair because Exmouth is so far away. But it does get down here from time to time. It might have been better to use a pair of maybe say Kalgoorlie or somebody that's more east-west than north-south, because the ducting tends to be north-south.
Yep.
So there are all those sorts of issues. But to answer your question, Jerry, yes, it's in hand.
All right, on. So as you can see there in WA, there is a bunch of 70 centimetre repeaters and one 6 metre repeater. And in WA, I can't see if there's any 10 metre repeaters. Oh yes, there is at Leeming.
Yeah, second one bottom.
Yep, one in Leeming.
Yeah.
I actually haven't used them in Australia, but when I lived in Malaysia, I lived in KL for 3 years, and I put up a 10 metre half wave antenna, and I could access a lot of the time the repeaters, the 10 metre repeaters in Australia, which was good fun. So now that some of the challenges and problems of repeaters. So the first one, I'm going to talk about desensing and receiver blocking. So this thing called desensing, you may have heard, or desensitization, you may have heard people talk about it on air. So any transmitter, no transmitter is 100% pure in terms of output. There is always, as you can see down the bottom of this diagram, much lower down, but there is a bunch of noise that's generated because all electronic circuitry has noise in it. In this case, what appears is let's call it phase noise. So it can be the original oscillator, for instance, that ends up producing the transmitter's output. There is some phase noise. What that means, as the electrons do what they do, they don't always do it exactly right, and you get very slight differences in, say, transmit frequency. What that means is the frequency might be dead on, or it might be slightly off, or whatever, and you end up with this thing called phase noise. Now, because our receivers are so close to the transmit frequency, only 600 kilohertz apart, you can see here the receiver is right in the phase noise of the transmitter. Okay. So it's caused by the transmitter not producing perfectly clean RF and these skirts of noise. Righto. The second very similar situation is called receiver blocking. And what happens, the front end of your receiver is made to be fairly wide because, say, you might want to operate from 144 to 148 megahertz, for instance. So the front end of your receiver might look something like that. So over many megahertz, you only get a little bit of rejection. So what that means is signals only 600 kilohertz away are going to go all the way through to the mixer. Mixer is a non-linear circuit, and you end up with this strong transmitted signal coming through and getting in and kind of, let's say, overdriving the mixer, making it even more non-linear than required, producing odd products and so on. It's called receiver blocking, and very similar to desensing, it overloads and reduces the sensitivity of the receiver. Let's talk about desensing and receiver blocking. What it does, what it appears as you as a listener to the repeater, if, for instance, a weak signal triggers the repeater, when the transmitter comes on, it either produces this noise or it produces this front end blocking. The effect on the receiver is the receiver's sensitivity goes right down. So receiver sensitivity goes right down with a weak signal. The squelch closes, the carrier operated relay drops out, and the transmitter turns off. So receiver says, oh, we're good, we're all back to normal. But of course that weak signal is still there. And guess what? The transmitter turns on again because the carrier operated relay says, hey, that signal is still there. So what you end up with is a cycling of the repeater. The repeater just keys itself up and drops, keys up and drop, keys up and drop. So there are a number of solutions to that. One of which is, of course, we could move the receive frequency well away from the transmit frequency. Yeah, but of course, on 2 meters, we're only limited to 2 megahertz of FM. So there's a bit of limitation there. You could separate the receiver and transmitter antennas so that you get less transmitted signal into the receiver, and I'm going to talk about that in a bit. You can put extra filtering in the transmit and receive lines, and we're going to talk about that in a minute. And as you could see on those pictures of the repeater that Will had built, separating the receiver and transmitter and all the components into, say, die-cast boxes and improving the shielding between the components is a good way to do it. And the last one is a squelch tail. So rather than the repeater cycling rapidly, by having a long tail on the squelch, so when the carrier drops, when the incoming signal drops, the carrier holds on for a bit and then drops out. It's still going to cycle, but at least it's going to be a bit slower. Otherwise, you can imagine how it might get away from you. Righto.
It's 22
righto. Next thing, the next undesirable problem that we get with repeaters. In fact, we get it in all sorts of things, and it's going to be a topic for another night. But it's called intermodulation. So it's when you get strong RF signals in non-linear circuits. You get sum and difference products generated, and those sum and different products produce odd frequencies. Now, what does that all mean? As I said before, when I looked after the VK6 RAH repeater at Wireless Hill, it transmitted on 146.8 megahertz, received on 146.2 megahertz. It was located at Melville on Wireless Hill. Down the bottom of the hill, there was a broadcast station, 6 PM, which in those days operated on 1,000 kilohertz. Also down the hill, there was a non-directional beacon, an aeronautical beacon that operated on 400 kilohertz. Yep, everybody was happy, worked very well until it rained. And when it rained, the antennas at Wireless Hill were on a galvanized, triangular tower sort of thing. The water would get in between the bits of galvanized steel where they were bolted together. A bit of electrolytic chemical reaction was occurring, which actually produced a bit of non-linearity, produced all these little diodes. That would allow the 6 PM signal on 1,000 kilohertz to mix with the NDB signal on 400 kilohertz. The difference is 600 kilohertz. And guess what? That mixed with 146.8 and produced 146.2. So after rain, the bloody thing would just go off by itself with not only, the ident and all that sort of thing. You could hear 6 PM's music, and you could also hear the Perth NDB, PH, repeated every 10 seconds or so. So the solution was somebody, me, would then drive up to Wireless Hill with a bit of 2x4, climb the tower and hit all of the areas of the tower that were bolted together and looked a bit rusty, and just giving them a bit of a bash with a hammer or a bit of 4x2 would actually, get the electrical conductivity going, and the problem would go away. So that's about intermodulation. It actually ended up leading to that repeater being taken off the air, and Tick Hill was built instead. So
they are the Tick Hill frequencies there.
Yeah, that's right.
146.8, yeah.
Yeah, but of course they don't have that problem of 6 PM. Well, 6 PM isn't on 1,000 kilohertz anymore because of the 9 kilohertz sort of spacing thing. So that particular problem has gone away. But
it's just as well because you've gone away too. It'd be a long way for you to come with your 2x4.
Yeah, actually, you're right. I didn't think of that, Martin. Well done. Now, our repeater, 6 RMH, actually does have a little bit of intermodulation. You'll probably hear it. The repeater will key up by itself, make some odd noises, and then it'll stop. And I reckon that happens half a dozen times a day. And it is some sort of intermodulation like that. Is it worth doing anything about? Well, absolutely not, because you could be chasing forever to find what it is. It's just a bit of an inconvenience. Another technical night, I'd like to talk about intermodulation. So a couple more there. Mobile flutter. So on VHF, you get signals coming via multiple paths. Of course, as you're driving, those paths change, reflections off buildings and mountains and that sort of thing. You end up with the signal going up and down, varying. And now what that means, of course, is if you didn't do anything about it, the repeater would be turning on and off as you get that flutter. Another reason to have a squelch tail where the repeater just holds on for a second or two so that the flutter doesn't cause cycling of the repeater. And something actually I didn't mention about intermodulation. We're talking about repeaters. It actually applies to a whole bunch of other things. Transmitters, linear amplifiers, preamps, receivers, and so on. And that's why I'd like to have a talk about it at another time. The last nasty, annoying thing, set of them, accidental lockups. I actually haven't heard it for a long time, but certainly in the earlier days of operating on 2 meters around Perth, repeaters would just lock themselves on for whatever reason. And of course, there is intentional jamming, but the timeout timer reduces the problem of that a little bit by turning the transmitter off, letting everything go back to normal. And so that's another reason for having a timeout timer. So let's talk about antennas. If you had one antenna and you transmitted straight into another antenna, it's basically connected to the receiver, and that would cause a lot of unpleasantness. So one way of, particularly in the early days, of making sure that the transmitter didn't interfere with the receiver was to have separate antennas. And so now if you look at the radiation pattern of a dipole, the horizontal pattern is pretty well circular, but the vertical pattern in the light, say we're talking about vertical dipoles here, in the line of the dipole, you'll see there's a nice big dip in terms of sensitivity of the dipole. So what that means, you could, if your transmitter and receiver antenna were horizontally, were mounted horizontally apart, let's say, you'd get a big signal from the transmitter into the receive antenna. But if you mount them vertically apart, you actually get a much lower signal because of that big null in the radiation of a vertical dipole. Now, this little table, for example, in this example, with a 600 kilohertz at 2 meters, 600 kilohertz between transmitter and receiver, in the days when this was written, about a 58 dB separation between your receiver and transmitter antenna was required for a repeater to operate satisfactorily. So that would have been, if you had horizontal antennas horizontally separated, about 350 feet apart, so about 120 meters, something like that. But by putting the antennas vertically apart, for the 58 dB, you could get away with about a 40-foot spacing, so about 12 meters between the antennas. So that is so a solution to to reduce the amount of signal getting from the transmitted antenna to the received antenna. That's one solution. Generally doesn't work on its own. So we now introduce these things called cavity filters. This picture in the center, that's a pair of cavities, and it looks like high band VHF. So imagine a cavity. If you look in here, it's a fully enclosed conductive box. There's a tuning type arrangement in the middle to kind of vary the, you could say, like the capacitance inside from top to bottom, essentially. And this particular configuration has an input loop and an output loop. So these things act like very sharp series tuned circuits. Now, series tuned circuit at resonance, they have a very low impedance. Away from resonance, they have higher impedance. Now, because of the very high Q of these things, you can end up with a very sharp notch. Now, what that means is if you have a cavity or cavities in the receive line, you can notch out the transmitted frequency, and if if you have it in the transmitter line, you can get rid of some of that that spectral noise that's transmitted by tuning this to notch out the receive frequency. So the cavity filters work because of their physical size and the tuning via this internal capacitor type arrangement. These things act like a notch filter.
Looks nice.
The scale.
Okay, thanks. I'm just pointing at the cavity filter on the bottom left-hand side, for those of you who can't see where I'm pointing. This is a circular can, just a hollow can, and the 2-meter versions are about so tall. The UHF versions are about so tall. The 6-meter versions are about so tall.
Why do they have to be so big?
The frequency. The higher the frequency, the smaller, just like antennas. So 6 meters are
Resonant.
Is that because of the capacitance that you?
I don't know who came up with the idea that an empty volume could resonate at a certain RF frequency, but they must have been on something. But it works. And this thing here is a rod that you adjust, either pushing it down and up, and then fine tuning it to get it to the right
So
spot.
you can't use a variable air capacitor or something like that.
Well, you won't get the sharpness of the notch.
Okay.
And you've done it again, Mark.
Yeah, I know. I'm for those of us who can't see you, to say how tall a 6-meter cavity is.
The cavities are on the left and the right.
Okay.
Dear, oh dear. Right, I keep going. All right.
I guess the diameter is critical as well.
That was from Will's page.
That's from Will's page. That's right. Yeah, remember when I did that presentation about the 10.3 gigahertz or the 10 gigahertz record, and we sort of talked about waveguides. And you can consider a cavity to be a bit like a closed waveguide. So you end up with electromagnetic radiation standing waves inside the box, and it's all tuned by, as Martin said, by that center plunger. So in this case, these little things here, it's a threaded rod. Turn the threaded rod, and it moves in and out, and it changes the resonant frequency of the thing.
Yeah. Also, these little loops here, the input and the output. These are your coax connectors here, coming down into the loops, and all the loop is it just goes from the center core and around to the outer shield. Offhand, I don't recall the formula of how long they are, but we'll see a photo of one of our loops shortly. But the RF comes in one and goes out the other. I did know of somebody who made some VHF cavities out of old fire extinguisher cans, which was interesting. All right, so I just wanted to bring that out, that's just an empty can with that rod and the two loops, matching loops, and they can be turned to face each other or go that way, or any combination that you want to get the maximum across. When we got ours, they were designed for a commercial VHF frequency, which was higher than our allocation. So these loops were in fact smaller than what we needed. And we ended up taking those off and making new, longer loops. Okay, over to you, Mark.
Thank you.
Rod, any special material?
Just something that doesn't want to rust, and as far as I know. And there's also locking ferrule nuts on the top to, once you've got it in a position. You'll have a rough tuning just by pushing it in and out, and then fine tuning by tweaking.
Is that can you be plastic?
No, metal, all metal. Yeah.
All right, any other questions? Beauty, righto. So the next iteration is how do we do it with a single antenna rather than having a separate transmit and receive antenna? And this is now getting into the more modern stuff that I have absolutely no experience with, because back in the days, well, we couldn't do this, but it's it is being done, and being done very well. And the repeater that you'll go and have a look at very shortly has this configuration. So in this case, single antenna is fed into a thing called a duplexer, and a duplexer is a series of cavity resonators generally. And so the RMH one has 3 cavities on the receive side and 3 cavities on the transmit side. And by tuning those cavities very cleverly, be good if you had a vector network analyzer, of course. By tuning them very carefully, you can tune them so well that all of the RF, nearly all of the RF goes out from the transmitter to the antenna, and very little goes actually into the receiver, and nearly all of the RF from the antenna on receive goes into the receiver with very little loss. Once again, set of cavities, normally about 6, arranged so that only passes the receive frequency from the antenna to the receiver, the transmit frequency from the transmitter to the antenna, and filters out any RF from the transmitter going into the receiver. So the 6 RMH cavities that you will see very shortly looks like that. So here are those tubes, boxes on the top, input and output type connectors. Looks like N connectors, double shielded cable between them. Here's the tuning rod sticking out the top.
And the boxes that you can see, these cast boxes, are add-ons. And in there, I have little airspace caps and in single wire inductors to allow for the fine tuning of them. You've got 2 rows of 3 sets of cavity filters, and I'm just trying to see which way is which. Yeah, this is the transmit side in the foreground, I think, and that's the receive side there. There's a little T-piece. The antenna is there on that. So the way it works is that on the transmit side, the cavities are tuned to the receive frequency so that you don't get any whisker of receive frequency carrier coming out and going up there and into the receive side and then blowing up your reed. So that because it's tuned to the receiver frequency, the transmitted frequency goes through quite happily and out to the antenna. Similarly, on the receiver side, this is tuned to the transmitter frequency. So it's trying to cut out anything this is tuned to for the receiver frequency on this side, and out it goes. And to stop the transmitted side coming out of here and then going down this cable to the repeater side, this is tuned each one is a very sharp notch on the transmit frequency. So it blocks anything on the transmit frequency, which would just appear as a strong carrier on the front end of the receiver, and you put 25 watts into your receiver, you let the smoke out of the rig.
Martin, they're all in series, I gather.
These are in series with each other
two
down to there,
series.
and they're in series with each
And each
other.
one is just adding a bit more notching. They're just,
Yeah,
the
each
more you
one,
have of these things,
the sharper the skirt on the notch.
okay. So
And that's what
having 3 is better than 2 is better than 1, clearly.
Yeah, you've got to get down to around about minus 70 dB or better to allow it to do that. So that's how that works. And over here in the little picture, you can see the little loop that I can't remember if that's the new one, the one we built. I think that was an original one, and put the measuring gauge up there. Will 6UU was a great help in helping to remotely by email help us sort this out. Okay, over to you, Mark.
How critical is the tuning? Is it like an antenna? If you move something, the tuning goes out,
Yeah.
or can you shuffle things around and they stay tuned?
Once you've got it set,
yeah,
they don't travel very well in the back of the van.
Okay.
You know, so
But I mean, if you say move them or move something in the shack, does that affect that tuning? It's not like an antenna where you
No.
drop one end or raise one end and it all goes out of tune. None of that. Okay.
Once you
Mechanical objects, aren't they? Really?
Yeah. It's just plumbing. Once inside the boxes here, once you've locked that down,
yeah,
then it's not going to go.
So not influenced by outside influences.
Maybe temperature if it got really hot.
Yeah.
So really cold.
Not that critical.
Not in normal temperature conditions.
It's really
and-
just plumbing, that's right.
And the other beautiful thing about that is that, as Mark said, let's use one antenna for transmit and receive. We have the split. You know, you could have. I think they make the receive antenna highest. Is that right? I think so. But in that event, you know, you can get into it, but you may not hear it as well because they're in different physical places. But with this one, you know that the same antenna is working, the same way for both transmit and receive. Okay, over to you, Mark.
Our repeater, this cavity setup just works, in my opinion, just so well. I have heard very little desensing on our repeater. So you just don't get the cycling of the repeaters that of our repeater that you do on others. And that's all about how these cavities are tuned. As well, of course, as I said before, shielding between the boxes and that sort of thing. So I think our repeater just works so well in that respect. So well done, Martin, for building it so well, and for Will for helping you get it going so well. So here we go. So Martin, would you like to talk about the spectrum analyzer picture that you took of the cavity filter?
Okay, this is the. I don't have a tracking generator. You can see in the bottom here next to the button that says line, it says RF out. That's where a beautiful tracking generator goes. And they didn't put it in this one. And what that would do, it would allow you to see the transmit, the passband all in one hit. So you'd see the power going out in the notch as well for the other side. But what I've done here is with my signal gen, I've set it up at 146.250. I think that's what I'm on.
Yep.
Yeah, 146.250. And I was able to get the filtering to, for this is one can, just one can at minus 26.27 dBm. And to get the skirt quite narrow. So that's sort of notch that you're looking at. Then if you stack that with another two, we're into the 74s quite nicely. But it took a lot of fiddling and tweaking and threatening it with calibrated claw hammers and things like that. So that's what that is. Over here, there's another marker, and that's on the other end of it, the 146.850, which is the transmitted side, but I'm not transmitting on that side at the moment. But that's my spectrum analyzer. That was the exact same model that they had in the Army vehicles when we were up at Mount William that time, when they had those tracking things. I was impressed. All right, next one. Okay, now this may not look like much, but here you've got the 146.250, and this little blip is the 146.850. And I'm actually transmitting on 146.250. Am I? Yes. And no, I'm transmitting on the output frequency, 146.850. There's a little bit of a blip there, but I'm looking at this one. And so we've got minus 74, about minus 75 dBm filtering. Very, very sharp notch here. On the repeater's transmit frequency, which is 146.850. That's the output. So it's going into the duplexer, which is on a dummy load, and you can't see a whisker of the transmitted frequency appearing at the receiver end of the duplexer. So that's the last one was minus 20 something. This is now with all 6 cans, and we've got minus 74 to 75 dBm, which when I saw that, I knew that I could plug that into the radios, and they wouldn't blow up, because there's now not a whisker of transmitted RF coming out of the radio that's being allowed to sneak back to the input of the receiver. And that's what you've got to have. So the marker here, 146.250 at minus 74.98 dBm. And with that, I said, that will do. I locked it in place, carefully brought it here.
Was there a target figure, Martin?
I'm sorry?
Was there a target figure for the rejection? How many dB?
Yeah, it had to be, I think it's accepted. I stand to be corrected here. Minus 60.
Yeah, I think so.
I've seen it quoted in a few places.
I think minus 60 dBm is acceptable. But I was able to get it down to minus 74. Well, nigh on 75. And that's what a spectrum analyzer will let you do. That's a real one. Okay, over to you, Mark.
Oh, did you say you're giving me your spectrum analyzer?
Yeah, I'll send it by air now. It needs 2 people to pick it up.
Martin and I have this ongoing discussion about spectrum analyzers because he has the nicest spectrum analyzer in the world and I have the cheapest and nastiest one. I'm only very slightly jealous. Righto. So just before I go to using repeaters, I'm just going to bring up another picture here. Just bear with me. On antennas, here it is. Righto, can you see that?
This is at your place?
Yeah. So this is the commercial antenna at Rolleystone that VK6RAP is on. I don't know how high it is. It's bloody high. But commercial antennas on the top, UHF antenna there. There's a link antenna to Mount Saddleback. There's here is the repeaters 2-meter antenna and 70 centimeters. So we go down. There's a 6-meter repeater antenna there. More commercial antennas. 2-meter, 70 centimeter packet. Another commercial. Old UHF packet link. Go down further, more commercial. There's the Mount William Newslink repeater, Newslink link antenna, 70 centimeters, and X-RITI 2-meter engineering dipole. So I like this setup.
That's what
the reason you get such a bloody good signal so far from this repeater is A, it's in a great location, but it's a bloody high tower, and the 2-meter antenna is right up the top there. So if I shrink this down, look how high that is. That's ridiculous. Righto.
Mount William these days is just in a little 4x4 box trailer on the ground.
Yeah.
That's true. Righto. Let's keep going here. Okay. Righto. So now let's talk about how to use things you need to know when you're using repeaters. As I said, you need to transmit and receive on separate frequencies. So if you've got your brand new box from China, you'll need to program it in so that you transmit and receive on the different frequencies, 600 kilohertz apart, using the Wireless Institute charts there that I showed you before to find out the frequencies. Simplex means transmitting and receiving on the same frequency. So on 2 meters, for instance, 146.5 is a simplex frequency, 146.55 is another one. That's, you know, for those of us who actually like talking to people direct rather than through repeaters, that's called simplex. The repeater offset, in most radios, most of the 2-meter radios, the standard offset is already 600 kilohertz, but you can, in most of the radios, you can change that if for instance, a different repeater arrangement is required. I don't know what did I write direction for? I've got no idea.
Positive or negative offset.
Oh yes, there you go. Well done. Offset direction. Thank you, Paul. That's right. Below 147 megahertz, its direction is negative on 2 meters. So transmit 600 kilohertz lower. Above, you transmit 600 kilohertz higher in most cases. And as I said, on 70 centimeters, it's 5 megahertz. Righto. So the, yes, one more thing. There's very few in Australia, very few odd splits that aren't 600 kilohertz and don't conform to that configuration. There's actually one repeater about 80 kilometers from here at Goulburn, and it transmits on 147.925, sorry, you transmit on it transmits on 147.925, and you receive on, it receives on 147.325. So it's upside down, and it's in a really odd place. There's one frequency pair that was available. I understand they were having all sorts of interference issues with all of the standard repeater splits, so they ended up having to go to this upside down arrangement. But once it's programmed into your radio, it all works. The next one is the term reverse or anti-repeater. Anti-repeater, some of us old people use that term. Reverse you'll find on your radio. What that means is if you're operating on the receiver and you press the reverse on the repeater, you press the reverse button, it swaps the transmit and receive frequencies around. So you can receive on the input to the repeater, so you can hear if the direct signals, and if you transmit, you're transmitting on the output frequency of the repeater, so the person you're talking to could hear you direct. So very useful to see if you're able to hear people direct rather than through the repeater.
Another handy use of that is once I noticed Paul ahead of me on the freeway, and I knew he would have his radio tuned to our repeater, so I switched to reverse, and I talked to him because I was acting like the repeater. So he was listening to the frequency that I was transmitting on. I was able to ask him to go to a simplex frequency. Remember that?
I wasn't there.
You weren't there?
No, I was there. Of course I was there. No, I think the issue was that my antenna on my car wasn't as strong as yours, and I could hear you couldn't hear me.
Yeah.
Which says my antennas at my car wasn't as good as yours, in all seriousness. We saw each other, so we knew we were trying to.
Yeah, so I was able to, by switching that, I was able to talk to him.
Would you have to do the same?
No, he stayed as it was. So he was listening on the frequency. If we were both trying to transmit into the repeater, we'd both be transmitting on the input to the repeater and listening on the output of the repeater. We wouldn't hear each other directly. So by switching mine around, we could then talk to each other.
Okay.
That was all. Sorry about
It's
that.
crystal clear, even though we're only meters apart on the freeway.
All right.
All right, next one is to keep in mind when you're using a repeater is the timeout. So what that means is if you yap for more than 3 minutes, you get timed out. So nobody can hear what you're saying because you get cut off. And the timer on the repeater will only reset when the carrier operated relay drops out. So you have to stop transmitting, wait for it to drop out before anybody can use it. And as I said, it used to be required by the licensing regulator, and it's also to stop the system from just locking up and causing other troubles. Righto, and in combination, the squelch tail, as I mentioned, particularly for mobile flutter, so that mobile flutter doesn't cause the transmitter and receiver to keep turning on and off. When you let the button go on your 2-meter transmitter, when you're using a repeater, you'll hear the squelch tail. So that's a period where the transmitter hangs on for about a second or so before it drops off. The timeout timer will not reset until the transmitter turns off. So what that means is if you're using a repeater, remember when the other person stops transmitting, give it a period of time until the transmitter turns off, the squelch tail drops before you start transmitting. And that also allows other people to jump in as well. Okay, CTCSS, which is that thing we were talking about before. Which stands for Continuous Tone Coded Squelch System. I have to actually write that down. So this is this thing called subaudible tones. What CTCSS is Continuous Tone Coded Squelch System. These are audible tones. The CTCSS is actually a subaudible tone. So when you're programming for some locations, like over here, for instance, where there's so many repeaters all keying up at the same time, by having a particular subaudible tone encoded onto your transmission, then that will allow you to access only that particular repeater. So it's the repeater listens for that tone. If it hears it, the squelch opens and off you go. So that the Riverina repeater network that I mentioned before, they happen to use 91.5 Hertz as the subaudible tone. When you're programming your radio, you can actually program that in for that particular frequency, so that whenever you dial it up, that tone gets transmitted. So I made a mistake there. I'm sorry, I confused things with the DTMF. That's another topic. But anyway, on. Next thing about using repeaters, Echolink. Some or all of you may have come across Echolink and used it on our repeater. So that allows you, the primary configuration is you can use your computer at home to connect into the internet and connect to different repeaters around the world, or different people around the world using Echolink. So the Mandurah repeater has an Echolink connection, and so that means that no matter where you are in the world, you can access it via Echolink. Now, Martin taught me about something about Echolink that I didn't know this afternoon, which is not unusual. You want to talk about that, Martin?
Yeah, I've realized I didn't record a node number to try. Does anybody with a computer have Echolink?
Yeah,
you can't. I'm looking for the node numbers. I don't think the phones.
Phones don't show it.
Won't show it.
There are comparison. The phone app doesn't show the node numbers.
So.
yeah, no, 633
There you go. Jeff has just connected.
633 266.
Yes. Can you find, say, NASA node number? So what you can do, you can go to transmit on this, and then while you're transmitting, you can punch in the code of the Echolink node, and
3082.
3082. Have you disconnected?
I have disconnected.
Okay, so I'll try that. I haven't tried it tonight. So 3082. That was NASA, was it?
Well, it's
Yes,
communication.
it's somebody. PK6 Mike Juliet in Mandurah, Western Australia, testing. Right, let's just go over to the US, to our repeater here. I like to learn now, to remember how to disconnect.
So for
Oh, Florida.
Okay.
Okay.
So you have to press the PTT,
Yeah.
and then punch in the number.
Yeah, the DTMF.
You're dialing it up. So
Yeah,
the
yeah.
tones.
So you don't just have to wait for somebody to come up on Echolink. If you want to talk to somebody particular, and you can find their list.
Research. This doesn't.
So, Martin, how has our repeater got Echolink on it?
The magic of the 6MJ show.
The magic.
Which is, Paul, it's probably that's probably a topic for another night.
I
It's
think,
going into the 7th year.
yeah, Mark, just
Yeah, I can hear you, Peter, loud and clear.
It was
Very
Peter.
good.
Yeah.
So for those of us,
6MJ. Thank you, Peter.
for those of us on Zoom, what Martin was doing to access that Echolink node in Florida was just using the I don't know if you can see the picture here. So just using the dual tone medium frequency buttons on the microphone, and just entering the code. So it wasn't actually in Echolink or anything like that. But
On the motion, where is the camera?
No, a little bit more to your
it's a
left.
bow
That's
thing,
it.
anyway.
Sorry, on the Baofeng.
all right,
One-
okay.
Wonderful little radio.
So just by pressing the DTMF buttons, he accessed the Echolink system and was connected to Florida. So I didn't know that you could do that. Very good, Martin. Thank you. Righto. The last one is IRLP, the Internet Radio Linking Project, which is quite similar to Echolink, but you don't need. Or in fact, you don't use computers at all. It's all done using the DTMF buttons on your microphone, and including the hash and star buttons. And there's just a bunch of commands to connect to something. You press, I don't know, star something or other, and then you enter the node number of the station you want to connect to somewhere else in the world, and voila, it connects to the internet, and you're away and working. And it's nothing new. IRLP has been around for quite a long time, many years. Very few people use it, but it's there. It's not on the Mandurah repeater as yet, but Martin does actually have the board for it. So there's another thing to think about in the future. Any other comments, Martin, before we move on from IRLP?
No, I might get into more trouble.
Yeah, okay. Righto, and that kind of opens up to the digital modes, All-Star, D-Star, C4, FM, P25, and those are definitely a topic for another night. Because I know nothing about, I know a bit about P25, but I really don't know anything about the rest of them. So more research needed. We'll talk about them on another occasion. Righto. And the last one is amateur satellites, which Martin has been experimenting with recently. I've been experimenting with as well. Again, for another night. But amateur satellite is essentially, well, particularly the ones that use FM. It's just a repeater in a little box, flying at X 100 kilometers up in the sky, and they just work. So I monitor a number of those satellites, and just as they come over, they pop up, perfectly Q5. So there you go. Righto. Any questions on that stuff to date?
Mark, just a comment. I know we're not doing Echolink tonight, but the little slide you had before,
Yeah.
from Echolink, is quite old. And I say quite old because in my short time of being an amateur, I've discovered, well, I know that Echolink was based on PCs, but now every smartphone in the world, I think, can run it.
Yeah.
So we've leaped ahead in making Echolink accessible to almost anybody. It's amazingly accessible now.
Absolutely. I'm sorry, Paul. I forgot to mention that, you don't need a PC. You just use your mobile phone and it's there.
Pretty bloody brilliant. Which means you can be portable, you can be mobile, you can do all sorts of amazing things with Echolink, which wasn't expected by the people who designed Echolink in the first place.
Yep, particularly good during the birthday bash.
Yeah, so it's not tonight's topic, but it's a powerful tool.
Yep, absolutely. It's speaking of amateur satellites, one has just popped up over the horizon and I'm listening to it at the moment. And that is AO91. There you go. Righto. So another future meeting topic, as I mentioned before, is linking repeaters and maybe a PARG project to link the Mandurah repeater to the Mount William repeater, and maybe consider then moving the Mandurah repeater to 70 centimetres so we can actually have something that is easily deployable in the trailer. As Martin said, the 2 metre cavities don't travel well, but 70 centimetre systems are more robust, and that might be a better solution. But anyway, that's for the future. Any questions and comments on where we're at so far before we move on, folks? Righto. Okay, so now let's have a walking tour of the repeater.
All right, so there's they're the same cavities that we had on the slide.
Pass an SES torch.
That's better.
Oh, look at
Stop the torch for yes.
Yeah. Okay. Get some light. Okay.
Okay, so there you can see the cavities, and they're touchy. We don't want them to get bumped around. That's why we keep that cupboard locked.
Very fine adjustment.
Very
Extremely fine.
very fine adjustment, which can be knocked out pretty easily.
So it's not looking locked in there. I just wondered why that.
It's so many hours adjusting those. If somebody gave it a kick now, it would be just a disaster.
Be a disaster for that person.
Yes.
Okay, so just be careful up there. So if you want to just carefully close the door so we can see the repeater. All right, can you see the two motion radios?
Yep.
You can probably only see one, so it might be best.
They're both visible now, mate, on the video.
Oh, are they?
Yes,
Okay.
both video
Cool.
visible.
All right, so they're both on standby at the moment. So if I go to transmit here, the top one is the receiver. I think that's got RX on it.
Yep. No, the bottom ones.
Oh, I swapped them around, did I?
Yeah.
I did. All right, so you can see how they light up. The receiver is green,
Changes colour.
and the transmitter goes to dark blue. Now, when I let go, you saw the receiver, and that's transmitting the ID. Okay, so I'll press the PTT. They'll both light up. The bottom one is the receiver, which goes green, and the transmitter automatically sends it out. When I let go of this, you'll see the bottom one goes back to that color, but the top one continues to transmit. That's the tail. This is VK6 Mike Juliet, testing VK6 RMH. There.
And the blue's the tail, the last three let blue.
Okay. This is VK6MJ testing. Anyone from the PL Amateur Radio Group listening? This is VK6 Mike Juliet.
You'd be lucky, I'd never get anyone. That's right.
Southbounding, readable 5, go ahead.
This is purpose was to stop Ronnie Kirk with his first transmission.
Yeah, very good, Mark. Coming to really good quality. No problems at all. All right, I will also just give a quick rundown on what else is in that cabinet there.
Just a fraction to the left. your camera.
Yeah, there we go.
That's better. Thank
All
you.
right, so thanks, Mark. And can you see the DigiPeter equipment next to it? Back to you, Mark.
Which is the 2 boxes.
How can he access the repeater?
See the mesh network.
Is now in the conference.
It's a mesh.
VK2KI, VK6 mic to it.
Took my headphones off and accidentally disconnected. Yeah, all right, mate. And, what happens when I transfer to the net? VK2KI via the Field Amateur Radio Group mesh network.
Thank you very much, Mark. And that's good. You can see how everyone can see how the 2 rigs are working. Next to it, there we have the UHF DigiPeter. This is test equipment donated by VK6MJ, and that's on 439.050 simplex, and that's handling WinLink traffic and the like using an AA PK 96 TNC set in 1200 baud mode, and the little tricky jickies power supply to run that. And down below, you can see the main repeater power supply. So there we go. All right. Both the DigiPeter and the repeater are running on the same antenna. So not only do we have a duplexer in the cabinet next door, there's a little diplexer between the antenna and the repeater is a duplexer, which allows the UHF radio to hook into the same antenna that the VHF repeater is on. So that's not too complicated. I can explain that.
Does it make sense to everyone here?
Okay. Do you want to see any more from here, Mark? And if not, we'll return to the main room.
That's good, Martin. Can you hear me okay through Jeff's phone? Yeah, righto. No, that's excellent. Thank you. And holy dooly, you are up high, Jeff. No, that is excellent. I was wondering what that extra little box was, Martin, on the cavities, but you've explained that's the diplexer for 720 meters. So there you go. All right, excellent. So we'll see you all back in the main room.
Surely, yes.
Roger, basics and grade clearing from the repeater. You want the ladder?
No, yours is not going to pick up.
Yes, it's okay. We'll do that.
Okay, we're almost all back. How did that go?
That was very good, Martin. Thank you very much. And yeah, it came through very well and didn't need the torch. We could see all what was going on. So thank you for that.
All right. The only thing we haven't discussed is how you're getting through to the repeater on the mesh network.
Yep. For another time, I reckon.
All right.
Just the magic of mesh. and the magic of VK6MJ's shack. So this is what we talked about today or tonight, and thank you to Martin for helping put this together and for the technical updates, and thank you, Jeff. There was something about square rig climbing on masts and things, and I'm sure you look like you're about 120 meters up, Jeff.
That's the trouble, is, you know.
Hardly a challenge for a train to dig it.
Well done. So thank you for being the cameraman, and Paul, not sure why we couldn't get the audio from you, but thank you for trying anyway. Righto, that's all I have to talk about tonight. So now for questions. Over to you, everybody.
The identification board, I'm yelling, Martin's right there. Whereabouts is it? How's that getting booked in? You might have shown it up there, but I missed it. I'm sitting in here.
The ident board, the Idiomatic Mark IV, is connected to that umbilical between the two rigs. And
Cat 5.
yeah, the Cat 5,
Yeah.
that's carrying the audio from the receiver down to the transmitter.
Yeah.
And it's also got the carrier operated relay cable in there as well. It then, so the audio from that board patches in to the mic socket.
It's being injected, isn't it?
Yeah,
Being
the mic
injected
socket.
into the.
And it also handles the the PTT is handled. Yeah, by that board as well.
Okay.
Yeah. Because it's being controlled by the carrier operator.
Mark, one of your slides show the ident coming into the circuit somewhere, where it sits in the whole in the scheme of things. Your early slides.
Yep, I'll.
Yeah. So you can see the receiver, the core comes out, the audio goes to the transmitter, and the audio is and the ident comes down into the transmitter. In this case, that's going into the mic socket on the transmitter radio. And the Idiomatic also handles the timer. The radios themselves also have a timeout. So that's a final fail-safe to stop it from staying latched on. Well, thank you, Mark. That was great. Well done.
Pleasure. I'm pleased we had a really good number of people there. Hopefully it was of interest to some or all of you. The next technical and workshop night we'll talk about during the kind of at the next meeting, but it will probably be, so that's September. We can either talk about repeater linking, or
We lost Jerry.
more interesting, I think, will be a talk by Jeff about portable operation, summits on the air, the parks, the World WWF, and generally operating portable. But that's all to be sort of confirmed. So one or other of those topics, I think, will be up for September. And we'll see how we go.
Yeah, okay. Well, look, on behalf of everybody, thanks very much, Mark and Martin, for the presentation tonight. Like everyone else, used repeaters for the last 40 years, and a basic understanding, probably, I thought a relatively good understanding, but clearly my knowledge was deficient because I've learned something tonight. Finer points, particularly the cavities. I was aware of them, but never seen them, and didn't fully understand what they do. So, thanks, gents. Yeah, as for next month, yeah, we can. Yeah, we're still talking about it. As always, if anyone wants to give a presentation on a pet subject of theirs, knock yourselves out, because it's open for everybody. But if there are no takers, yeah, I had offered to talk about IOTA, SOTA, parks on the air, and just portable operations, and portable power, and QRP.
I'd love to get that topic myself. I watched that. Really interesting. Yeah.
Happy to do that. The interesting thing, I won't spoil what I'm going to present, but the interesting thing is that you might have heard of IOTA, Islands on the Air. I've done that over the years, particularly in the Pacific, but within 20 miles of here, a bit under 20 miles. There's an island we can activate. No, Penguin. Penguin or Garden Island. And in terms of summits on the air, we think that it's all flat around here. There are 7 international qualifying peaks within 60 kilometres. And in terms of PARGs, WWF, there are literally hundreds, including, I find that my QDH, home QDH is actually in one, the Land Howard Conservation Park. So in terms of activating QRP portable operations, either for islands, summits, or parks, there's stuff all within walking distance of where we are here. And so that's what I'll talk about, and how we can actually deal with rigs, batteries, antennas.
Do you think your FT817 will be back on the
That's twisty.
They're trying to put the smoke back in it now.
I can't do that.
Yeah, well, very good. And the other thing I'd just like to add, I really want to thank everybody who's contributed to our list of technical topics. As we've said before, we've got about 600,000 topics to talk about, and now that I've got lots of input from lots of people, thank you all. And I think we've got a really good number of very interesting topics to talk about over the next X number of years. But as I said, or as Jeff said, if anybody has another topic they'd like to talk about in particular, or have talked about, then yeah, we'll just slot it in. Sounds good.